अच्छा जी. So we are starting lecture 8. That is the first lecture after midterm examination. So before this, we have, if you remember, if we have studied about the second order differential equation and about homogeneous and non-homogeneous equations. So if you have a second order homogeneous or non-homogeneous equation, so for this type of differential equation we have studied some methods. For non-homogeneous method we have studied the undetermined coefficient method, the method of variation of parameters. But the question is, if you have a higher order differential equation, so these methods become more complicated. Because if you have a third order differential equation, suppose this is y3 y triple dash plus this is 3y double dash, this is plus suppose y dash, this is plus y, this is equal to 0. Now this is a homogeneous equation of third order. So to search the solution of this differential equation, we will find the complementary solution, that is yc. So we will write the characteristic equation of this differential equation. So the characteristic equation of this differential equation is m cube plus 3m square plus m plus 1 equal to 0. But if you remember, this will become a cubic algebraic equation. This will become a cubic algebraic equation. So the cubic algebraic equation is complicated to solve as compared to the quadratic equation. So, to find the three roots of this characteristic equation, suppose this is the characteristic equation m cube plus 3m square plus m plus 1, this will be equal to 0. So how to find the three roots of this algebraic equation? So this is complicated as compared to the quadratic equation. But if this is the higher order, that is of order 4 differential equation, so it will become m4 some like equation. So it becomes more complicated as compared to the m cube type equation. If it become a fifth order differential equation, so it become more complicated. So if the higher, if we are facing the higher order differential equation, so the characteristic equation is actually complicated to handle. That is to find the roots of this characteristic equation. So what is the alternate procedure to find the solution of this equation 1? This is equation 1. So if it is non-homogeneous, then it become more complicated. So if it is homogeneous, it is complicated. If it is non-homogeneous, it become more complicated again. So what is another procedure to solve to handle this problem? So समझ आ रहा है जी?
Yes, sir.
Yes, sir.
Okay. So the next chapter we will study how to handle the higher order differential equation into a system of first order differential equation. So what is that procedure to convert a higher order differential equation to a system of differential equation? So let's start this example. Let I am taking y is equal to a variable x1. So y dash will become x1 dash. Let x1 dash is equal to x2. So y double dash will become x2 dash. This is x2 dash. let x2 dash is equal to x3. Y triple dash will be equal to x3 dash, which is equal to, let's suppose this is equal to x4. So आपने third order तक derivative लेने हैं, because in differential equation the derivative is third order. So, and first take y is equal to x1, then y dash will become x1 dash. Let take x1 dash is equal to x2, then take y double dash, so it will become x2 dash. Let this is equal to x3, and take the third derivative, this will become x3 dash, and let x3 dash is equal to x4. So, putting these values in equation number 1 implies, what is y triple dash? Y triple dash is actually, y triple dash is not take at x4, so this is x3 dash. मैं आगे समझा दूंगा. So what is y triple dash? This is x3 dash. So x3 dash this is equal to minus 3 y double dash. Minus 3 y double dash is actually x3. This is x3. And plus y dash means x2 minus x2. And what is y? This will become minus y, and minus y is minus x1. So this is minus x1. This will become minus x1. So this is from equation 1, and these two derivative, which we are supposing that x1 dash is equal to x2 and x2 dash is equal to x3, these are another two first order differential equations. So the combination of these three, this is one equation. Suppose this is equation A, this is equation B, and this one is equation C. So the combination of these three equations is known as system of first order differential equation. G, how to convert? So the question is how to convert a higher order differential equation, this one, into a system of differential equation. So now this is a system of differential equation x1 dash. चलिए मैं इसके ऊपर लिख लेता हूँ. This is equal to x1 dash equal to x2. This is x1 dash is equal to x2. x2 dash equal to x3. x2 dash equal to x3. So now these three equations is known as the system of differential equation. If the differential equation is of third order, so the system of differential equation will be three. The system of equation will contain three equations. If this is a fourth order, so the convert system, that is the first order system of differential equation, will be contain four equations. जी समझ आ रहा है?
Yes, sir.
So if we take another equation, suppose this is equal to y triple dash, so suppose this is y double dash plus 2y dash, yeah, 2y dash plus y, this is equal to 0. This is a second order differential equation. So how to convert this into a system of differential equation? So what we will let y is equal to x1, y is equal to x1, you will take y dash, this will be equal to x1 dash, this will be equal to x1 dash, and let x1 dash, जहाँ पे derivative आ जाए, let take it another variable, that is x2. y double dash, this will become x2 dash. अब यहाँ पे भी derivative, there is also involved derivative, but actually you will not take it equal to x3 because now we are reached at the higher order derivative which involved in the equation. So उसके बाद उसको another variable की equal न ले. So this is what? Now, if you put these values in equation 1, this one, so you will get what? Y double dash means x2 dash. This is x2 dash equal to minus 2y dash, minus 2y dash, minus 2y dash means minus 2x2, minus 2 into x2, and minus y means minus x1. So this is one equation, and another equation is this one, जहां पे आप डेरिवेटिव को another variable की equal लेते हैं. This is x1 dash equal to. So if you solve this system involves actually two variables, unknown variable. One is x1, another is x2. So if you combinedly solve this system of first order differential equation, you will get x1 and x2. So if you obtain x1, so actually x1 is equal to y. So y is what? Y is the solution of the given equation, this one. So if you solve actually this system, you will get x1 and x2. x2 is actually the derivative of that solution. Y dash means, y means solution and y dash means derivative. It's the derivative. So x1 means the solution of that differential equation and x2 means its derivative. So मेरे ख्याल में आप समझ में आ गया होगा. So first of all, the question is, we are actually not solving at this stage this system of differential equation. We are understanding that how to convert a higher order differential equation into a system of differential equation. यहाँ तक clear है? Is it clear?
Yes, sir.
So now the next question is, we can write this system in the form of x dash is equal to ax. We can write this system as in this form, where what is x dash? X dash is equal to actually, what is x dash? X dash means a column vector, that is x1 dash, x2 dash, x3 dash, this is x. What is A? A is the coefficient matrix. Coefficient matrix means the coefficient of x1, x2, x3, जितने भी variables हैं. So what is the coefficient of x1 in first equation? 0. What is the coefficient of x2 in the first equation? 1. What is the coefficient of x3 in the first equation? This is 0. So this is matrix A. What is the coefficient of x1 in second equation, and what is the x1 in third equation? That is minus 1. What is the coefficient of x2 in the second equation? That is minus 1, and another is minus 3. So this is your A. What is your x? What is your x? This will become x1, x2, x3. This become x1, x2, x3. So every first order differential equation, if it is homogeneous, remember this, Now this system is homogeneous. Why? G. Why this is homogeneous? G. Hello?
Yes, sir.
जी ये सिस्टम ऑफ इक्वेशन होमोजीनियस क्यों है? चलिए मुझे ये बता दे व्हाट इज x1 x2 x3? What is x1 x2 x3? x1 x2 x3 are the derivatives of dependent variable. x1 is dependent variable itself. x1 is dependent variable itself, that is x1 is y, if you see it. x2 is the derivative of dependent variable and x3 is the double derivative of dependent variable. So actually what is it? This is the in this system there is only the derivative or the dependent variable itself exists. There is no independent variable term which exists in this system. ये समझ आ रहा है?
Yes, sir.
अगर यहाँ पे कोई प्लस टी होता, यहाँ पे प्लस 2 होता, यहाँ पे कोई प्लस 3t होता, so then this will become what? This will become non-homogeneous. Now in this case this is homogeneous. ये clear है?
Yes, sir.
Okay जी. So every homogeneous system can be written in the form of x dash is equal to ax. Remember this point. Remember this point. Every homogeneous first order system can be written in the form of x dash is equal to ax, where a is what? A is the coefficient matrix. Coefficient matrix means the coefficient of x1, x2, x3 जितने भी वेरिएबल्स उसमें इन्वॉल्व हैं. अगर ये 4 इक्वेशन है, so the equation number of equations are 4, so the A matrix will be 4 cross 4. Similarly, the column matrix x dash will contains 4 rows, x1 dash, x2 dash, x3 dash, x4 dash, if the number of equations are 4. Similarly, the column vector x will contain 4 rows, x1, x2, x3, x4. So remember this point, that every homogeneous system of first order differential equation can be written in the form of x dash is equal to ax. ये clear हुआ?
Yes, sir.
Okay जी. So if this is non-homogeneous, so we can write it, this is plus f of t, where f of t means यहाँ पे suppose if there is 2, there is suppose t, there is suppose plus t square. So what will be f of t vector? Then what will be f of t vector, if you remember? So write the first term, so this will become 2, this will become t, and this will become t square. Suppose this is again t square, suppose. So this will be f of t vector, this is t square. So if this is non-homogeneous, so every non-homogeneous first order system can be written x dash is equal to ax plus f, where f is the non-homogeneous term, which is 2t and t square. So ये clear हुआ ना? So every homogeneous system can be written in the form of x dash is equal to ax, and every non-homogeneous system can be written in the form of x dash is equal to ax plus f. Is it clear?
Yes, sir.
Okay. Now, another question is, now we are moving towards the solution actually. How to search the solution of a system of differential equation. how to search the solution of the system of differential equation. So if you have x dash equal to ax, if you have x dash is equal to ax, so let's see, let's start this one. if you remember, अगर आपको याद हो, this is what, this is y dash equal to what, ky, if you remember. So what was the solution of this differential equation? If you remember, that is c1 e power ky. If you remember, so that was the solution of this differential equation. याद है आपको?
Yes, sir.
Okay जी. So what do you expect the solution of x dash is equal to ax? Can you expect the solution of this system is equal to x is equal to g k e power g? आप क्या एक्सपेक्ट कर सकते हैं इसका सॉल्यूशन? When y dash is equal to ky, so what was the solution? If you remember, y is equal to some constant c1 e power k into y. ऐसे आप एक्सपेक्ट कर रहे थे ना? So what will be the solution in this case? ऐसे होगा?
Yes, sir.
So let I am taking this e power lambda x naught a, that is this one. So the solution of this system of differential equation can be expected in this form: x is equal to k e power lambda x. So if you take the derivative, this will become x dash, and x dash will become k lambda e power lambda x. So if you put the values, so x dash will become k lambda e power lambda x equal to a, what is x, k e power lambda x. Actually I'm putting these two values in this equation: x dash is equal to x. So if you cancel this e power lambda x with e power lambda x, so you will get k lambda will be equal to a into k. Now what is this k? This k is not a real number. This k is actually a matrix. So you cannot cancel this k with this k, because this is in product with another matrix. You cannot cancel it. So if you take lambda I minus a, this is k equal to 0, लिख सकते हैं इसे आप?
Yes,
Yes,
sir.
sir.
Okay जी. Now this is a system of differential equation. So what will be the characteristic equation? Now this is a homogeneous system, if you remember. Lambda I minus k into x equal to 0. ये आपके पास homogeneous system होता था, linear algebra में आपने पढ़ा होगा. So this is a homogeneous system. So if you have a homogeneous system of homogeneous system of equations, so always remember that the determinant of the coefficient matrix will be equal to 0. So the characteristic equation of this is determinant of if you have a homogeneous system, so always remember that the coefficient matrix determinant will be equal to 0. So lambda I minus a is actually the coefficient matrix. So this will be 0. This will be 0. Okay, ji? समझ आ रहा है?
Yes, sir.
ओके जी. सो ये लीनियर अलजेब्रे की तरह है, बिल्कुल सेम उसी प्रोसीजर से मैं चल रहा हूं. अच्छा जी. So this is also known as the characteristic equation, if you remember. So if you solve this equation, this will be some algebraic equation. If you solve, this will be some type lambda cube plus lambda square plus, if you remember. So this will give you the values of lambda, that is called eigenvalues. याद है?
Yes,
Yes,
sir.
sir. Yes, sir.
So if you suppose if you obtain lambda is equal to 1, lambda is equal to 2, and lambda is equal to 3, so what we did then, for each eigenvalue there will be corresponding eigenvector. So you put the value of lambda is equal to 1 in this equation and you find the values of k. वहां पे आपके पास x फाइंड होता था, x1 x2 x3, यहाँ पे k फाइंड हो जाएगा. Suppose k is what? K find हुआ. In this case the value of k is suppose 1, 2, 3. This is eigenvector corresponding to what? Lambda is equal to 1. Similarly, for lambda is equal to 2, you will get again the value of k, and k will be a solution set. That is, k will be जिस तरह आप इसको x1 x2 x3 put करते थे ना, so you will put k1 k2 k3 and then you will find the values of k1 k2 k3. So again for lambda is equal to 2, you will get another set of k1 k2 k3. So you will get again another eigenvector. For lambda is equal to 3, you will get again another eigenvector. So what is so suppose, so what is solution? Solution is this one. Solution is this one. So what is x1 actually? What is x1? x1 is actually k1 e power lambda 1x. What is x2? What is x2? That will be k2 e power lambda 2x. What will be x3? x3 will be k3 e power lambda 3x. So k1, k2 are actually the eigenvector corresponding to the lambda 1, lambda 2, lambda 3. So actually you will get the solution set x1, x2, x3, and this is called the solution of the given system. G. जी हेलो.
Yes, sir.
अच्छा जी, स्टार्ट हमने कहां से लिया था? इफ यू रिमेंबर, स्टार्ट हमने कहां से लिया था? वी आर the question was that every first order homogeneous system can be written x dash is equal to ax. That was the question. Now how to search the solution of this system? So if you look into the structure of this system, so it is actually in the form of y dash is equal to ay. So actually we are searching the solution in the form of x is equal to k e power lambda x. K e power lambda x, we are looking the solution in this form. So if you take the derivative of this x dash and putting the values in this equation, so So actually you obtain this set, and so the determinant will be equal to 0. You will get the values of eigenvalues, and if you put the eigenvalues in this system, you will get the value of k. K means k1. K means the set of values 1, 2, 3. Suppose. Similarly, for each eigenvalue, you will get eigenvector, and you put in this solution set x is equal to k e power lambda x. If lambda is lambda 1, this k will become k1, this will become x1. If this is lambda 2, this will become k2, and this will become x2. If this is lambda 3, this will become k3, this will become x3. So you will generate a system of, you will generate a solution, set of solution. जी अगर कोई क्वेश्चन है तो आप पूछ सकते हैं. There is any question you can ask at this stage. नहीं है जी? Can I move forward?
Yes, sir.
Okay, जी, okay, thank you. So now we are moving towards the slides. So these are the outlines. This is the first order system of equation dx1 by dt. I am writing at x1 dash. dx1 by dt means x1 dash. This is g1 t x1 x2. मैं इसको different तरह वो function represent कर रहे हैं, so you can represent it by g1 t x1 x2 x3, and so this is a general system actually. Now this is a general system again, but this is a non-homogeneous system because there exists f1t, f2t and f2. जिस तरह मैंने पहले कहा, if there exists t, if there exists sin t, if there exists 2, so this will become a non-homogeneous system. So again, the procedure was same. So this is a higher order differential equation. Suppose dny by dtn minus a naught by a n y minus a1 by a n y dash. So how to convert this into a first order system? So you take y is equal to x1, you take y dash is equal to x1 dash, but take x1 dash is equal to x2 again, and y double dash will become x2 dash, and x2 dash take it is equal to x3. So continue this procedure and you will get a system of equation. That is x1 dash is equal to x2, x2 dash is equal to x3, and x3 dash is equal to x4. And this last equation is actually obtained from by putting the values in the given system. In the given differential equation, this one. So ये ऐसे समझ में नहीं आएगा if you take some specific example. Suppose this is a specific example 1. So convert this. The question is convert it into normal form. That is, the normal form means convert it into the system of differential equation. So this is actually a third order differential equation 2y3 y triple dash minus y minus 4y dash plus 6y double dash plus sin t. So let's take first of all take y higher order equal to the one side and the other derivative and the dependent variable at the other side. Now this is non-homogeneous equation or this is a homogeneous equation? First question is this. This is non-homogeneous. Yes. So if the differential equation is non-homogeneous, so the system of differential equation will always be non-homogeneous. So let's see how to convert it into system of first order differential equation. Take y is equal to x1, y dash is equal to x2, and y double dash is equal to x3, and then you have to take another derivative y triple dash. So this is the system x1 dash is equal if you convert it. This is another example. Rewrite the second order differential equation is a system in the normal form. This is 2 y double dash. So let's take y is equal to x1, y dash is equal to x1 dash will become x2, y double dash will become x2 dash. So if you put the values, so you will get a system of equation. So this is, I think, simple one. This is again example 3. So ये कुछ examples हैं. अच्छा जी, ये दो example जो हैं ये छोड़ दे 5 and 6. अच्छा, exercise for practice. इसमें जो 4 questions हैं पहले, 4 question ये आप attempt करें. So the question is convert these second order and higher order differential equations into a first order system of differential equation. So मेरे ख्याल में easy है. Is it easy?
Yes, sir. First four are easy.
Okay. So first 4 question, I'm talking about first 4 question. So now this is matrix and system of linear first order differential equation. So the question is, every system can be written in the form of dx by dt means x dash is equal to ax plus f of t. जैसे मैंने पहले लिखा, x dash is equal to ax plus f of t. That is, this is a system. Suppose dx1 by dt means x1 dash is equal to a11 tx1 a12 tx2 plus this plus f1 t. So what is the x dash vector in this case? This is x1 dash, x2 dash, x3 dash, xn dash, and what is the coefficient matrix? That is a11 a12 a1 and this one. What is f of t? This is f1 t f2 t. So this system can be written as dx dash is equal to ax plus f of t. So if f of t is equal to 0, so this will become homogeneous and this will become x dash is equal to ax. ये तो समझ में आ रहा है ना?
Yes, sir.
अच्छा, ये अभी जो मैंने पहले इसको एक्सप्लेन किया था, this was this thing. So the example one, write this system into matrix form. G, write this system into matrix form. कैसे लिखेंगे? This is actually non-homogeneous system. So what is the non-homogeneous system general form? X dash is equal to what? Ax plus f of t. याद है?
Yes, sir.
X dash is equal to ax plus f of t, the general form of non-homogeneous first order system. X dash is equal to ax plus f of t.
Yes, sir.
So what is x dash? What is x dash? X dash actually dx by dt. What is a? A is actually the coefficient of x and y. That is minus 2, 5 and 4 minus 3. X is x plus what is f of t? F of t is et minus 2t and t 10t. Clear है ना?
Yes, sir.
Okay जी. So what is x dash? This is ax plus. You can also write it in the form of 10 et plus minus 2t minus 210 into t. यहाँ पे देखिए कि आप लिख सकते हैं इसको ऐसे, फिर मुझे बता दें आप.
Yes, sir.
Okay. So this will become x is equal to minus 2, 5, 4 minus 3 x plus 10 into et minus 210 into t. So this is actually the matrix form of this system. बाकी हमने सॉल्व नहीं करना था. Only write the system of equation into a matrix form. So this is a homogeneous system, no need. Now the question is example 2. Verify that x1 is equal to this one, x2 is equal to this one, is the solution of x dash is equal to ax. कैसे करें इसको? जी, how to verify that x1 is the solution of x dash is equal to ax? How to verify that x dash is equal to x1 is equal to this one is the solution of this system, x dash is equal to ax. जी
देख में पुट करेंगे।
जी देखिए x डैश equal to ax. What is a? So write the values of a. This is x. What is a? This is 1 3 5 3 1 3 5 3. Suppose I am verifying that x1 is the solution of this system. So what is the value of x1? We have to write the value of x1. That is, what is the value of x1? The value of x1 is, suppose this is given e power minus 2t and minus 2, sorry, minus e power minus 2t. This is actually x1. This is x1. So actually replace this x by this x1. So let this is x1 dash. So x1 dash will become what? This will become 1 3 5 3. So this is what? E power minus 2t. If you replace x by x1, this will become minus e power minus 2t. So if you multiply this matrix with this column vector, so you will get what? You will get 1 multiplied by e power minus 2t, this is e power minus 2t, and then plus minus 3 e power minus 2t, minus 3 e power minus 2t, and then 5 e power minus 2t, and then minus 3 e power minus 2t. So if you simplify it, you will get 1 minus 3 is actually minus 2 e power minus 2t, and this will become 2 e power minus 2t. So the derivative of this column vector is this one actually. ये है इसका derivative.
Yes, sir.
Okay जी. So actually this x1, if you multiply a with x1, so actually you obtain x1 dash. So this is satisfied. This is satisfied. So x1 is the solution of this system. Similarly, you can replace x by x2 and you can verify this one. So this is the procedure for that. So now this is for practice. Write the given system in matrix form. This is 1 and this is 2. This is 3 4. Write the given system without of use of matrices. So from matrix form, convert it into the first order system of equation. If you have a matrix form, how to convert it into a system of equation? ये तो easy है मेरे ख्याल में. जी, let's see. From left side there will become x1 dash. x1 dash will become 7x1 plus 5x2 minus 9x3 plus 0 e power 5t minus 8 e power minus 2t. This is first equation of the system. Clear hua? Is it clear? Second equation will be x2 dash is equal to 4x1 plus x2 plus x3 plus 2 e power 5t minus 0 e power minus 2t. This is second equation of the system. What will be the third equation? x3 dash will be equal to 0x1 minus 2x2 plus 3x3 plus e power 5t minus 3 e power minus 2t. Is it clear? G.
Yes, sir.
Okay, G, thank you. So write this in the form of system. So ये simple है. This is again another example. Consider the homogeneous system of in matrix form. You can write it. This is dx by dt. Dx by dt means x dash. नीचे y dash है. This is 1 3 5 3, the coefficient matrix, and this is xy, where x is xy, x dash is 1 3 5 3 into x. So x1 and x2, x1 dash will become, so ये again वही example है, वही example, same example. So इसके fx1 and x2, if x1 and x2 are the solution of this system, x dash is equal to ax. This is x dash is equal to ax, and x1 is this one and x2 is this one. These two are the solution of this system. What is the system? X dash is equal to ax. So what will be the general solution? General solution will be c1 x1 plus c2 x2. Is it clear? Suppose you have a system x dash is equal to ax. This is a system. So if this system contains two variables, so the solution set will become x1 will be equal to some value and x2 will be equal to some value, and this will be the two solutions of this system. If this system contains 2 cross 2 system, if this is a 2 cross 2 system, so the solution set will be x1 and x2. कैसे होगा ना? जी. Okay, Ji. If this is a third order system, so there will be x3 also. There will be x3 also. Solution for x3 also. So what will be the general solution? General solution will be x is equal to c1 x1 plus c2 x2 plus c3 x3. This will be a general solution. Is it clear now? G. Okay, G. Okay. So this is जैसे मैंने पहले explain किया था, if you take x is equal to k e power lambda t, so if you take the derivative and put the values, so you will get a minus lambda I k equal to 0, and if you take the determinant of a minus lambda equal to 0, so you will get the a characteristic equation of the matrix n represented the nth degree polynomial in lambda. So if you put these values, you will get the eigenvalues and the corresponding eigenvectors k1, k2, kn. So the general solution will be what? What was the general solution? This is c1 x1. What is x1? If you remember. What is c1 and what is x1? k1 e power lambda 1x. What is x2? k2 e power lambda 2x. ये देखे ना, यहाँ से हमने निकाला था x is equal to k e power lambda x, so x1 will become k1 e power lambda x, x2 will become k2 e power lambda x. So if you put these values, so the general solution will become this one plus c3 e power K3 e power lambda 3x. Is it clear now? जी, so this is the general solution already मैं explain कर चुका हूँ. Now this is example 2. So what is the matrix form of this system? This is x dash is equal to ax, where a is 2, 3 and 3, 1. So what is the characteristic equation? G. Chale, I am writing this system, I am solving this system to clear the situation. So this is a simple system. I am solving this system. So the system is x dash is equal to and y dash equal to, what is this system? 2x plus 3y, 2x plus 3y and the second equation is 2x plus y. So the general form of this system is x dash is equal to ax. What is x dash? X dash means small x dash. You can also give it x1 and x2 also. So this is x1 dash and y dash. This is equal to a. What is a? A is 2, 3 into 2, 1. What is x? Capital X? Capital is x is actually x and y. So this is what? The system. Sorry. Okay. So what is the characteristic equation? So this system can be written as, what is the characteristic equation? Directly write the characteristic equation. Characteristic equation is determinant of lambda I minus a equal to 0. This is the characteristic equation. So what is lambda I? Lambda I means 0, lambda, this is lambda into 0 and 0 into lambda. This is actually lambda I. Minus a. What is a? A is actually what? A is 2, 3 and 2, 1. So if you take the determinant equal to 0, so you will get the quadratic equation on lambda. That is this one, lambda square minus 3 lambda minus 4. Lambda square, this will give you lambda square minus 3 lambda minus 4 equal to 0. So you will get two values of lambda. One is minus 1 and another is minus 4. Is that clear? यहाँ तक clear है?
Yes, sir.
Yes, sir.
Yes, sir.
So how to find the eigenvector? For eigenvector, you will take lambda I minus a k equal to 0. If you remember the equation, हमने theory में पढ़ा. So if you put lambda is equal to minus 1, so this will become what? Minus 1 into I means 0, 0, 0, minus 1, minus a means 2, 3, 2, 1, and this is what? What is k? Now, k is actually what? Small k1 and k2 there is. If matrix A is 2 cross 2, so the value of k will be k1, k2. If the matrix A is 3 cross 3, so it will be k1, k2, k3. What is 0? 0 is actually a 0 matrix. That is 0, 0. So if you take minus 1, minus 2, this will become minus 3k1. This is equal to 0. Sorry, minus 3 and plus k2. What? Plus, sorry, minus 3k2 equal to 0. This is
सर यहाँ भी
minus.
माइनस होता है.
Yes, यहाँ पे minus आ रहा है. This is minus. This is minus. Now, second equation is 0 minus 2, that is minus 2 k1, and minus 1 is minus 2 k2. This is again equal to 0. So if you take minus 3 common from one equation and minus 2 common from second equation, and you subtract these two equations, so as a result you will obtain k1 plus k2 equal to 0. So this is from two equation you will obtain a one equation. So actually now the equation is 1 and the variable is 2. So you have to take one variable as free. So let k1 as 1. Let k1 as 1. So what will be k2? K2 will be minus 1. So what is the eigenvector? Eigenvector is actually 1 minus 1. And this eigenvector is corresponding to what? Lambda is equal to this value. Similarly, you will put again minus 4 and you will get again another values of k1 and k2, and that will become the eigenvector corresponding to lambda is equal to minus 4. So this is for lambda is equal to minus 1, this is the system, 3k1 plus 3k2, 2k1 plus 2k2. So if you simplify this system, you will get k1 is equal to minus k2. So if you give the value of k1 is equal to 1, so you will get k2 is equal to minus 1. So this is the eigenvector. For lambda is equal to 4, similarly is the case, so the eigenvector is 3, 2. So what is x1 now? What is x1? x1 is actually the one eigenvector multiplied by e power lambda 1 t. Lambda 1 is actually minus 1. So what is x2? Another eigenvector multiplied by e power lambda t. So lambda is minus 4. यहाँ पे इससे गलती हुई है, मेरे ख्याल में ये minus 4 है या 4 है. Let's check. This is 4 actually. So roots are minus 1 and 4. So you will get these two solutions. What are the solutions? X1 is this one and X2 is this one. So what is the general solution? X is equal to C1 X1 plus C2 X2. And this is the general solution. So if you take the general solution, so take X of t is equal to first component and Y of t is equal to second component. So this is now the solution of this system. What? Of this system. This is x, dx by dt is equal to 2x plus 3y, and ty by dt is equal to 2x plus y. So this is the solution set. That is x is equal to c1 e power minus t plus 3 c2 e power 4t, and y of t is equal to this one. जी समझ आ रहे हैं?
जी सर.
ओके जी, ओके, सो मेरे ख्याल में ये सिंपल है. नाउ द क्वेश्चन इज, if the roots are complex, if the roots of a characteristic equation, that is the values of lambda are complex. So this is a theorem. Suppose K is an eigenvector corresponding to the complex eigenvalue lambda 1 is equal to this one. So what will be, suppose this is an example. So this is another example, dx by dt, dy by dt is x minus 1, 5, 4xy. So the matrix A is actually 6 minus 1, 5, 4. So what will be the characteristic equation? Determinant of A minus lambda I equal to 5 minus 6. So this is equal to 0. So lambda 1 is 5 plus 2i and lambda 2 is 5 minus 2i. So what is the solution? So procedure is same. So if you take, so you will obtain these two equations. So if you take k1 is equal to 1, so you will get the value of k2, which will be 1 minus 2 iota. So this is another eigenvector corresponding to what? 5 plus 2 iota. And this is for eigenvector corresponding to 5 minus 2 iota. So what is solution? Solution is again x1 is equal to 1 eigenvector e power eigenvalue into t, x2 is equal to eigenvector e power eigenvalue into t, and the general solution is c1 and this one. ये clear हुआ?
Yes, sir.
Okay जी. So this is another example, example 5. So again the same, lambda 1 is 2 iota and lambda 2 is minus 2 iota. So again the same procedure. This is example 6. Again the eigenvalues are 1 plus iota, 1 minus iota. So if you continue the process, you will get. Now the question is, if the roots are repeated, when the roots are multiplicity of 2, that is if lambda is 1, 1, 3, 2, उसमें से दो रूट्स अगर रिपीटेड हैं, so how to perform the solution? So the question is, जिस तरह हम यहाँ वहाँ पे करते थे, if you remember, if the two roots are, if the values of m are repeated, suppose m is equal to 1 and 1, so हम solution कैसे लिखते थे, याद है? c1 e power x plus c2 x e power x, याद है? याद है ना? This is why if the roots are repeated, याद है ये प्रोसीजर होगा, उसके साथ आप t मल्टीप्लाई करेंगे. So this is the procedure. If one root is k1 and another is k2, and k1 and k2 are both are multiple of each other, so you will write c1 k1 t e power lambda 1 t and c2 k2 e power lambda 1 t if lambda 1 and lambda 2 are same. So multiply 1 with t, c1 k1 t e power lambda 1 t, c2 k2 e power lambda 1 t. So the procedure is same. So what will be another solution? Remember this, x2 will be equal to, this is another solution, k t e power lambda 1 t plus t plus p e power lambda 1 t, where what is p? जी, चलो एक एग्जाम्पल पे चलते हैं, थ्योरी फिलहाल आप छोड़ दें. दिस इज एन एग्जाम्पल. सो इफ यू write the characteristic equation, so it will be determinant of a minus lambda I will be equal to 0. So the roots are minus 3 and minus 3. ये क्लियर है?
Yes, sir.
ओके जी. For lambda is equal to minus 3, you will get this equation, this system of equation 6k1 minus 18k2 equal to 0, 2k1 minus 6k2 equal to 0. So if you take 6 common from equation 1 and 2 common from equation 2 and you subtract these two equations from each other, you will get k1 minus 3k2 equal to 0. So if you select, suppose k2 is equal to 1, so k1 will become what? 3. So this is eigenvector 3 and 1. So what is the first solution? X1 is equal to eigenvector 3 1 multiplied by e power lambda 1 t. Lambda 1 is minus 3 actually. So this is one solution. Now what is another solution? Remember this. If the roots are repeated, so इस slide को थोड़ा सा देख ले. This will be another. This will be the second solution. X2 will be equal to kt e power lambda 1t plus p e power lambda 1t. Remember, इसको याद रख ले. X2 will be equal to kt e power lambda 1t plus 2 plus p e power lambda 1t. This will be another solution. So x1 तो find हो गया ना. This is x1. Now what is second solution? Second solution will be, उसके लिए मुझे p की जरूरत पड़ेगी. Then we will put it, x2 will be equal to what? k1 t e power lambda t plus p e power lambda t. What is p now? P is actually the solution of a plus 3ip equal to k. So if you solve this, you will get the value of p. So यहाँ पे theory में mention है, P is actually the solution of this system. A minus lambda 1i P into equal to K. K means the first eigenvector. ये clear हुआ? जी. चलिए आप थोड़ा सा देख ले उसको. Other, if there is any problem, then we will discuss it in next class. So if you remember, if you solve it by hand, so I think it will be clear. So this is another example. This is 3 cross 3. So the characteristic equation is, now there are 4 repeated roots. So for 4 repeated roots, again the procedure is same. This is x1 x2. So मेरे ख्याल में ये आप खुद try करें and practice exercise भी try कर लें. जी.